Ma unnara?
Yes, ma'am.
So why we need to take temp1 and temp2? Why can't we advance p1 and p2?
మ్యామ్ P1 లో 4x క్యూబ్ ఉంది కదా మ్యామ్,
Mm.
P2 లో 2x ప్లస్ 1 ఉంది కదా మ్యామ్.
Ah.
4x 4x క్యూబ్ ఏమో P2 లో ఉన్న టర్మ్స్ ఒక్కొక్కటి సబ్స్టిట్యూట్ చేసుకోవడానికి దాన్ని వాడుకుంటాం మ్యామ్.
Mm.
అలాగే ఇప్పుడు P2 అనుకోండి మ్యామ్, అలా యూజ్ చేసుకున్నప్పుడు ఒక్కొక్క టర్మ్ ని టెమ్ టు ఈక్వల్ టు P2 అనుకుంటాం మ్యామ్.
Mm.
అలాగే ఇప్పుడు P2 లో అన్ని టర్మ్స్ అయిపోయిన తర్వాత మళ్ళీ ఫస్ట్ కి అది P1 ఇంకో టర్మ్ ఉంది కదా మ్యామ్,
Mm.
ఆ టర్మ్ దగ్గరికి రావాలంటే అప్పుడు P1 ఈక్వల్ టు టెంప్ ఈక్వల్ టు P1 అని వాడుకుంటాం మ్యామ్.
Yes, very good, very good. Okay, I hope you understood, students. Just 62 has explained. Okay, that's why we are taking this temp1 and temp2. You should not move p1 and p2. P1 and p2 should always point to first index, or sorry, first node only. Okay, next, see, we need to advance the pointer. First temp1 must point to 4x cube. Next temp2 must point to 2x. After multiplying, temp2 must point to the next term 1. So you need to repeat this. You need to advance the pointer. If you want to advance the pointer, you need to use while loop. While temp1 not equal to null, while temp2 not equal to null. Already I have explained. Now see here. Now what I am doing? You are creating a node. See this one. Temp equal to struct node malloc. Malloc means what is the use of malloc? It is going to create. It is going to allocate memory at the time of execution time. Okay. See, now you are creating a node. What is that node name? Temp. Temp. Coefficient field. Next, sorry. Exp field and next field. Okay, you have created. Next step. See, now what you are doing? Temp of COE FF equal to FF. Okay, I'm sorry. F or FF keep. Okay, if you are using COEF, use COEF. If you are using COEFF, your wish. Okay. Now see this step. See this step. This one. Temp1 of COEFF. Temp1 of COEFF is nothing but 4. Temp2 of COEFF is nothing but 2. See, 4x cube into 2x. First you are at 4x cube. Next temp2 is at 2x. 4 into 2 you are getting 8. So that you are assigning to temp of quotient. That means you are creating some node. To that node resultant you are adding 8. Completed. Next. Next, this part. Temp of exp. See, 4x cube into 2x power 1. Here exp means exponents you need to add. That's why temp1 of exp plus temp2 of exp. 3 plus 1, cube plus 1, 4. 8x power 4. Yes, created. You have created. Completed. Next. Temp of next equal to null. That means temp next field will be null. Okay, completed. Now what you are doing? You are calling a function, insert function. What insert function is doing? Let us see. I will erase this 1 second. See, now you are calling insert function. This is insert function. Now control goes to this function. Now see here, this is a temp, right? This is temp. 8x power 4 resultant 4x cube into 2x. COEFF. You can use COEF or COEFF your wish. EXP. Next null. Name of this node is temp. Okay. Now what you are doing? You are passing P3 and temp to this function. You are calling a function. Now control jumps into this function code. Now P3 is nothing but null. Initially P3 you are getting null. What is temp? This node. You are passing this node to this function. Now what is happening? See, initially step 1. See this step 1. Step 1 and step 2. P3 equal to null. Whether it is true or false? Yes. P3 equal to null. Null equal to null. True. If it is true, what you are doing? See the steps. See the first step. If statement you are using, you are testing P3 equal to null kada. Yes. P3 is null initially. So what you are doing? These two steps you are doing. P3 equal to temp. That means this P3 for the first time, this P3 is pointing to C. You know that P3 is a resultant, what is this? Resultant linked list, right? That means P3 must point to the 4x cube. See, you have multiplied 4x cube into 2x, we have multiplied, you got some resultant. That means a 2 P3 must point to the first node, right? This is the first node of the resultant. That's why what you are doing, P3 equal to temp. So P3 points to temp node. P3 is resultant completed. Next, what you are doing, return P3. That means return. See, whenever return statement is there, control returns to the calling function. That means control goes to the calling function where this function is called. See here, this function, it will go here, it will come here. Next, temp equal to temp2 equal to temp2 of next. See, 4x cube plus 3 2x square plus 1. This is temp1 is pointing to 4x cube, temp2 is pointing to 2x square. Just now you have completed 4x cube into 2x square. So 2x, right? 2x. You have completed, right? Next, what you need to do? You need to multiply 4x cube with 1. If you want to multiply with 1, this pointer should advance to 1. That means this temp2, T2 or temp2 must point to the next node. Next node, what it contains? 1. That's why temp2 equal to temp2 of next. Now temp2 points to T2 points to 1. Again loop repeats. See, inner loop repeats. Inner loop, see, again you are creating a node. Again you are creating node of the name is temp. Okay, now temp of COEFF equal to temp1 of COEF. Temp1, what is temp1? 4x cube. That means 4 into, what is temp2? See, temp2 of COEFF. Temp2 is 1. See, we have completed, multiplied 4x cube with 2x. Now you need to multiply with 1. Temp2 is pointing to a node which contains element 1. Coefficient is 1. See, x power 0. Okay. Coefficient is 1. So 4 into 1 you are getting, you are inserting 4 in temp COEFF. Next EXP and next. Okay. Now see. Next. Temp of EXP equal to temp1 of EXP. What is temp1? 4x cube. See, you are not at all moving temp1. First you are moving only P2 term. First 2x, later you are multiplying it like that. Okay, after completing 2x plus 1, then you will advance T1 pointer. Okay. Where we are? See, temp1 of EXP is nothing but 3x cube plus temp2 of EXP. What is that? X power 0, 1 x power 0, 3 plus 0, 3. You are inserting in temp of EXP, this one, temp of EXP, you are inserting into temp of EXP. Okay, completed. You have created a node and multiplied, and this is the temp. Now see, null, this is the temp, right? This is the temp. Now, after this statement, what is the statement present? See, after temp equal to temp of next, this statement, see this one. After this statement completed, right? Temp of next equal to null, yes, I have inserted. After this, see here, you are calling, what you are calling? Insert P3. P3 means already we have created previous node. This is P3. Now what you have created? 4x power 3. You have multiplied 4x3 into 1. That means 4x3 node that you are passing. Okay. Now here a function will be called. That means you are going to that function call. What you are passing, remember, see, P3 is there and you are passing this one. I will erase this and I will write down. Okay, see. I'm sorry. Now control came to this function. What is P3? This one. This is P3. What is temp? Just now you have created. Temp 4x cube, right? 3 null. This is temp. Okay. Now what you have to do? See, after 8x, see, you got 8x power 4. After 8x power 4, you need to use 4x cube, right? That means this P3 must link to the temp node. See here. First, what you need to do is, see here, temp 3 equal to, why you are taking temp 3? You should not move P3. P3 should always point to the first node only. That's why I'm taking another pointer temp 3. Okay, now temp 3 points to P3. You should not move P3. That's why we are taking temp 3. P3 should always point to first node only. Now temp 3 not equal to null. See, what you have to do means P3 is 8x power 4, right? 8x power 4. Temp, what is temp? This is P3. Temp is nothing but just now you have multiplied 4x cube into 1. 4x cube into 1 is 4x cube only. Now you need to check whether these exponents are equal. See, previously there is one term. You got 8x power 4. Now you got 4x cube. You need to check whether again you got x power 4 or not. That means exponents are equal or not. You need to check. See here. Coming to the algorithm, see the algorithm. See, temp 3 of exp equal to temp of exp. What is temp 3? P3. Temp 3 of exp is 4. 4 equal to temp of exp. Temp is pointing to 4x cube. Just now you have multiplied 4x cube into 1. That is what it is pointing. So temp of exp is nothing but 3. 4 equal to 3 or no. If you are getting, see, for example, if you have multiplied like this, if you are getting something like 4x power 4, first లో ఏమొచ్చింది 8x power వచ్చింది. Next time if you got 4x power 4, what you need to do? You need to add, right? So that's why this is the step. You need to add. This is the step. If you got same exponent, see, you got same exponent, you got 8x power 4. Next, if you are multiplying again, you got 4x power 4, means what you need to do? Temp 3 of COEF equal to temp 3 of COEF. That means 8 plus temp of COEF. What is temp? Temp is pointing to 4x power 4. Just think you got 4x power 4. That means you are adding 4 plus 8 plus 4. That you are adding to the P3. And you are freeing temp because, see here, what is happening? 12, see, 12, what is this? 1 second. Hmm. 12x power 4. You are getting 12x power 4. There are two nodes. This is 8x power 4. One node is there. There is another linked node. 4x power 4 is there. Actually, you need to simplify, right? You should get only one node. 12x power 4. That's what you are doing. Temp 3 of COEFF equal to temp 3 of COEF ante 8 plus temp of COEF ante 4. 8 plus 4, you are getting 12. Okay. Now, you are freeing temp. See, there must be only one node. Free temp. Free temp means, see, what you are doing? You are deallocating memory for x power 4. Now P3 points to 12x power 4. This is what these two statements are doing. That's why you kept these two statements. That, see, I hope you understood, students. Why you put these two statements? See, these two statements. Why you put means, if you are getting same exponent term, second time when you are multiplying, if you are getting same exponent term, you have to simplify it. There should not be like this 8x power 4 plus again 4x power 4. Like that it should not be, right? 8x ax square plus bx plus c, like that, like in that form it should be there. That's why you have to simplify. That's why you are adding both coefficients and you are deallocating memory for temp x power 4. You are deallocating only one node you are maintaining. That's why these two steps. Okay. If both are not equal, what is happening? See, not equal. 8x power 4 is there. Now you got 4x cube. See, 4 is not equal to 3, right? Exponents are not equal. If not equal means what you are doing? Just wait. See what you are doing. You need to traverse up to the last node. 1 second. This is the last node. P3 contains only 8x power 4, null. Now temp is 4x cube, 4x cube null. This is temp. This is P3. Okay. Temp 3 also points to this node only. See, P3 you should not ever move. You have to use temp 3 only. See, only linked list contains P3 contains only 8x power 4, only one node. Now what you have to do? You need to traverse up to the last node, because after this 8x power 4, you need to link like this. See, I'm sorry. After 8x power 4, see, like this you need to link. 4x cube you got, you need to link like this. That means to last node you need to traverse up to the last node. After the last node you need to insert temp node address in next field. Okay, but this is only last node. Already I have explained how to traverse to the last node. Students, here there is a small mistake. See here, not temp 3 of null. Already I said how to traverse to the last node, while temp 3 of next not equal to null. Please put this one, not temp of null. This is wrong. Instead of that statement, please put this one. For example, I will explain why I put this one. For example, see, this is P3. This is P3 something. Now see, now we have created a temp node. This is P3. Think this is P3. Now see, you need to see. 1 second. Please try to understand. This is very easy. See, after this node, after last node of P3, you need to insert this newly created node temp. That means you need to traverse up to the last node, this node. Up to last node you need to traverse. If you want to traverse, already I said how to traverse. See, here instead of last we are taking temp 3. Instead of last pointer we are taking temp 3. Already in previous class I have explained how to traverse to the last node. You need to use a temp 3 of next not equal to null. See, this is wrong. While temp 3 not. So here, see here. See, with this statement, please try to understand. I'm not explaining this. Already have explained. While temp 3 of next, I'm not explaining that. Next, not equal to null. Not equal to null. What you are doing? See, these statements, see, I'm not, see, there is if temp of 3 exponent equal to temp of exponents, right? Step 5. I'm not taking that step 5. Why? Because you need to understand what is these steps means. See, temp 3 equal to temp 3 of next. How it looks like, just in previous class I have explained how to traverse to the last node, right? Instead of temp 3, I took last variable. Here there are some steps. Don't bother about that. There are some steps. But see this logic, how it looks like, just in previous class I have explained how to traverse to the last node. So this statement is nothing but you are traversing to the last node, and what you are doing, see, you are traversing to the last node. After traversing to the last node, after while loop is completed, what you are doing, see here, initially this is P3. Initially P3, okay. 8x power 4 you got. Now you got 4x cube. Null. This is temp. See, P3, this is only first node and this is only last node, right? That means temp 3 will be at the P3 only. Chudandi. See, try to understand. Try to understand, see here. See this logic, 1 second. While, see this one, while temp 3 of next not equal to null, true or false, temp 3 of next not equal to null. Null not equal to null, false. False means these while loop statements will not get executed. Control comes to the step 7. See here, control comes to the step 7. This is the end of the while loop. Step 6 is the end of the while loop. why it is not, see here, see why this statement is not executing, step 5, step 6 is not executing. Why? Because this step 5 and step 6 is nothing but you are traversing up to the last node. But coming to here, see, coming to here, you got only one node. P3 contains only one node, 8x power 4. This is only last node. That's why you are not at all comparing 8x power 4 and 4x cube. You are not at all comparing. These statements are not at all executing because this while condition is false. Sorry, here you need to put temp 3 of next. Okay, instead of temp, see there is a small mistake, students. Please note down, there is a small mistake. Instead of temp 3, you need to put temp 3 of next, not equal to null. These statements will not executed. You are not at all comparing. This is only the last node. You are not at all comparing. Just try to understand. Okay. Now what is the step? While loop is not at all executing because this is only the last node. Temp 3 will be at last node only, 8x power 4. Now what you are doing, see this statement, temp 3 of next equal to temp 3, see this is the sixth statement is end of the while loop. Sixth statement will not get executed. Step 7 will get executed when while condition is false. Temp 3 of next equal to temp. See, once again see. Okay. See here. Temp 3 of next equal to null equal to temp. I'm sorry. Temp. You are assigning temp address. Now you have 4x cube into 1. Previously you have multiplied 4x cube into 2x. You got this node. Now what you are doing, 4x cube into 1, you got this node, second node. You need to link, right? You need to create linked list. You need to link. That's why that's why you are taking this statement. That's why you are doing this insert operation. See, temp 3 of next. This is a temp 3. 8x power 4 is temp 3. Temp 3 of next, you are putting temp address. See here. You are putting temp address. That means in this next field, temp 3 of next means this one. I'm erasing. See, in this, you are putting temp address. That means it is linking to temp. You have created a linked list, completed. Now P3 is nothing but 8x power 4, 4x cube. We have created a linked list. I hope you understood, students. This is how, in this way, it is executing. Now, once, see here, these statements, repeat these statements. These statements, for example, you have multiplied 3x into 2x. Sorry, 3, right? 3 into 2x. For example, you have multiplied 3 into 2x. 6x you are getting. What you are doing? You are creating a node. 6x power 1, right? Temp. Now, what is P3? 8x power 4, 4x cube. This is P3. Now, what you are doing? See this one. You need to traverse. First, you need to check whether you got x power 4 term or not. Remember, these statements, what these statements are doing. See, temp 3 of exponent equal to temp of exp. Temp of exp is nothing but 1. 6x. You got 6x, right? That you need to compare with P3's exponent. What is P3 exponent? 4. 4 equal to 1? No. See, why you are doing is you are simplifying. For example, when you are multiplying 3 with some other thing, if you are getting x power 4 term, you need to simplify it, right? That's why you are putting these statements. Otherwise, no need. See, if exponents are not equal, then no need to add these statements. These statements will not get executed. Like that, you need to traverse and you need to traverse to the last node. Now come to the last node. This is temp 3. Come to the last node. See, while traversing, you need to compare exponents with newly created node. 3 equal to 1, no. If this 3 equal to 1, 3 equal to, if there is 6x cube, okay, for example, you have created, for example, you have multiplied, you got 6x cube. What you need to here, there is 4x cube. What you need to do, 3 equal to 3, x cube equal to x cube. You need to add 6 plus, what is this, 4 plus 6. 10 you need to put, and you need to free this node. Free temp, see this one. See this one, this statement, free temp, right? That means you are freeing this node because you have to simplify it. There should be no 4x cube again plus 6x cube. There should be no 2 nodes. There should be only one node. That means you need to simplify it. That's why you are using these statements. That's why you are using free temp. Okay. Here you didn't get 4x cube. You get only 6x. Okay, 6x, 6, 1, null. This is temp. Now you need to traverse up to the last node. While you are traversing, you need to check the exponents with these statements. If exponents are equal, then you need to add the coefficient and you need to free temp. Otherwise, no need to add. What you are doing otherwise, that means see, 3 is not equal to 1, right? 4x cube is not equal to 6x square. See, 4x cube, x cube is not equal to x power 1. 3 not equal to 1. No need to add. Then what you need to do, if you don't want to add, what you need to do? See here. Temp 3 of next. What is temp 3? You have traversed up to the last node. You have traversed up to the last node. Temp 3 of next equal to what you are doing? Temp 3 of next equal to temp. That means a temp address you are adding to the last node next field. This is. I'm sorry, once again I will erase. This is what you got, right? P3 always points to the first node. Now temp 3 is at last node. You need to traverse up to the last node. This is temp. One second. 4x cube plus 3, 2x plus 3. This both are completed. Okay, 6x, right? 6, 1. Now what you need to do? You need to traverse up to the last node and you need to put temp 3 of next to temp. That means in temp 3 next you need to put address of temp. That means you are creating linked list. Remember this insert operation, what it is doing? It is creating the linked list. Is it clear, students? If you trace out it, you can understand well. Have you understood? This insert function is creating the linked list. While creating the linked list, it is comparing the exponents. Okay, remember, it is comparing the exponents. Because if exponents are equal, for example, you got 8x power 4, 6x power 4, what you need to do? You need to add and you need to simplify it. And you should create only one node. That's why you are using this operation, free temp. After simplifying, you are inserting in a P3 node and you are freeing temp node. So that you are simplifying. If both are not equal, you are traversing up to the last node varaku traverse ayi. In that last node next field, you are adding newly created node. That means a linked list is creating. If you trace out, you can understand very well. See, this multiplication algorithm, it will take at least 15 minutes of time. If you trace out, you have to understand, right? So just trace out. This is the algorithm of what is this matrix? Sorry, polynomial expression multiplication using linked list. This is the algorithm. If you trace out using some example, take some example. Just now I took, right? Like that, take and then trace out. If you trace out twice or thrice, and then you can understand, so that in examination you will You will, at least you will be able to attempt. You may not write correctly, but you will get marks. If you are not at all practicing, means, see, you cannot remember all these things. So what is temp of next? What is temp of exp? You cannot remember all these statements. If you practice twice and thrice only, you will get. See, unit 1 problems. If you see the problems, if you're not at all practicing, if you see, at least you can attempt. But unit 2, if you are not at all practicing these algorithms, it is really very hard to you to remember. You cannot by heart all these things, so you lose marks. So I request all the students to practice algorithms. Like this, you need to trace out. If you trace out only, you will get, otherwise you can't get. You cannot by heart. Only unit 2 you cannot by heart. Remaining things, okay, it's okay. You will get problems. In unit 3, there will be some problems. You can easily score marks. But unit 2 only, you cannot score marks if you practice these algorithms. If you write algorithm exactly only, you will get marks. See, coming to unit 1, if you solve the problems, you may get half marks. If you are not writing algorithm, if you don't know how to write the algorithm, then also you can get half marks because you are solving the problem. It is very easy to solve the problem. But coming to unit 2, here there are no problems. Everything's are algorithms, and you need to take examples, and you need to show according to this algorithm what actually this algorithm is doing. That means definitely you have to write algorithm. There are no examples to solve. So you need to practice twice or thrice. All unit 2 is all about algorithms only. Okay, students, unit 2 is completed. Next class I will start unit 3. Are there any doubts?
No, ma'am.
Okay, please practice unit 2. Okay, students.